Hi everyone, in this part of the series, we'll talk about generic type constraints, and it'll be a very quick and easy tutorial, so let's get right into it. Let's imagine that we want to write a generic function that is going to accept any type, but we still have some requirements for that type. So let's imagine that we want to create a function that is called log item ID. It's going to receive as an argument an item of type, let's for now just set it's going to be type T, right? You already know that. In case you haven't seen this syntax, I recommend that you go back to my first tutorial of the series, which was about generic functions. But if you've already gone through it, you're familiar with this. So this is just a regular generic function. But let's say that we don't want to allow for any type. For example, we don't want to allow for strings or numbers. We want this T to be an object with at least an ID property, and then it might have any other number and type of properties, but our minimum requirement is that it is an object with an ID property. How can we do that? It's very simple. Here inside of these angle brackets, after the T, we will write the keyword extends, which you're already familiar with from classes, extends. And now we wanted to extend an object with an ID of type number. Most of the time the ID is number. It could also be a string in some cases. But that's it. Right now we will allow this to be filled in only by objects that have at least the ID number. Of course, they might have other properties. That's why we're saying that the T extends this object. It's not equal to this object. It extends it, but this is the bare minimum that has to be satisfied. And inside of here, I can now say item, and now see, when I use the dot operator, it already suggests that I can use the ID property because I'm convinced that it will have the ID property. All right, I think that's enough for the function definition. I can just test it now. I can say log item ID, and now if I try to pass in a string, this is not gonna work, right? Because this is not an object that has an ID property. Same goes for a number. This is not going to work. But if I plug in an object, now let's start with an object that only has a name property. Name, Bencho, or first name, whatever we call it. It's not gonna work. Why? Because you don't have the ID. But if I now add the ID property, let's say just one, this is working perfectly fine. And of course, I can now use the same function and pass in a different structure of the object. Of course, I still have to provide the ID, but now I can say email, Bencho, or let's say Mincho this time, gmail.com. This is going to work perfectly fine, and we can add age. 45. So these objects have a different structure for the most part, but with one constraint. That's why it's called a type constraint, that they have to have an ID. So that was everything. Of course, you could work out some more complex examples, but most of the time, if you use extends at all, it would be for simpler functions like this one. So I hope this tutorial was helpful to you. If you have any questions, don't hesitate to write them down in the comment section, and I'll see you in the next tutorial.